In this video, we're going to extend your knowledge of parallelograms in order to prove that a particular quadrilateral is indeed a parallelogram. So in order to prove that a quadrilateral is a parallelogram, you're going to use any one of the following 5 reasons. Reason number 1 is you can show that both pairs of opposite sides are parallel in that parallelogram, and then by definition, it has to be a parallelogram. So both pairs of opposite sides parallel make any quadrilateral a parallelogram. The second way that you can prove that a quadrilateral is a parallelogram is to show that both pairs of opposite sides are congruent. Because we know that any quadrilateral where both pairs of opposite sides are congruent has to be a parallelogram. You can show that one pair of sides has both of those properties, both parallel and congruent, and that will make your quadrilateral a parallelogram. You can show that your quadrilateral has both pairs of opposite angles congruent, and if both pairs of opposite angles are congruent, we know that your quadrilateral has to be a parallelogram. And the last possibility has to do with diagonals. We know that anytime the diagonals of a quadrilateral bisect each other, that quadrilateral is a parallelogram. So that's kind of a lot to bite off or to chew off. You need to know these 5 strategies. So you need to know that any quadrilateral with both pairs of opposite sides congruent, automatically going to be a parallelogram. A quadrilateral with diagonals that bisect each other is automatically going to be a parallelogram. A quadrilateral where one pair of sides is both parallel and congruent, automatically going to be a parallelogram. So again, it's really important that you know those 5 strategies. So let's go ahead and take a look at how we would use this in a proof, because I know you're excited to get started on the proofs. In number 1, we're told that segments AB and CD are parallel. So the first thing that I'm going to do is go mark those fellas parallel in my diagram. We're told that segments AD and BC are parallel. So I'm going to go ahead and mark those in my diagram. Now what I know from the given information is that because that quadrilateral has both sides of opposite sides parallel, I know that quadrilateral must be a parallelogram. And because that fella is a parallelogram, I know that the statement I'm trying to prove true, angle 1 is congruent to angle 2, I know that has to be a true statement because once my quadrilateral is a parallelogram, I know that its opposite angles have to be congruent to one another. So this is a relatively simple, short, straight to the point 3-step proof, as long as you make the connection between both pairs of opposite sides being parallel and parallelogram, and then the parallelogram has opposite angles that are congruent. So I'm going to go ahead and start with those parallel sides. And I'm going to go ahead and lump them right into the same given because they're both true for the same reason. I can go ahead and put them right in the same statement. So I know that's a true statement because it's given to me to be a true statement. And because those both pairs of opposite sides are parallel, I can go ahead and conclude that ABCD is a parallelogram. And that's because a quadrilateral, which I'm going to abbreviate quad, and I have to be very specific here and say both pair, and I'm going to use the word opposite even though I really don't have to. That's going to be important in some other proofs that we write. Both pair of opposite sides, and these sides are parallel. It is a parallelogram. And now that that fella is a parallelogram, I know that angles 1 and 2 have to be congruent to each other because a parallelogram has opposite angles that are congruent. Now that's not the only way that you can write that proof. You can do something a little bit longer with parallel lines and all your related angle pairs, but that's the shortest and most efficient way to prove those 2 angles are congruent to one another. All right, so there's what a Euclidean proof in plane space might look like. Let's jump onto the coordinate plane now with number 2. In number 2, we're given this quadrilateral with those particular vertices, and we're being asked to prove that quadrilateral ABCD is a parallelogram. So the first thing that I'm going to do is go ahead and plot those points on my coordinate grid so that I have a good idea or a good visual picture of exactly what I'm looking at. I'll use my straight edge to go ahead and connect the vertices. And because I'm on the coordinate grid, I have some options here. I could do the first thing that I could do or prove, just like I did with the first proof, through slopes, I can prove that this fella has both pairs of opposite sides parallel, and therefore he would be a parallelogram. So I could use slopes to prove both sides of opposite sides parallel. I could use the distance formula to show two pairs of opposite sides that are congruent. Or I can do kind of a combination of the two. I can use both slope and distance to show one pair that are both parallel and congruent. So the idea here is that there are a lot of different correct ways to write this proof, and just because you write it differently than I do doesn't mean that one of us has made a mistake. So when there's a question or a doubt in your mind, please don't be afraid to ask and say, hey, Ms. McCann, did I do this correctly? I think I'm going to go with option number 3 just so that I get some practice in doing both slope and distance formula. So I'm going to go ahead and pick the top side and the bottom side, but you could pick the left side and the right side and still use the same approach. So anytime I use a formula, remember that the very first thing that I need to do is write it down on the page. And I'm going to tell the reader of my proof that the first segment for which I'm finding slope is segment AB. So when I find the slope of segment AB, the change in y's is going to be 4 subtract 3. I want to make this a little complete and say slope equals, and the change in x is going to be 3 subtract negative 1. So the slope here of this segment, 1/4, which I can probably confirm just by looking at the graph, up 1/4. Now I need to find the slope of the bottom segment. So CD, his slope is equal to -2 subtract -1 all over -4 subtract 0. And I'm going to highly recommend that you get your calculator out and plug that entire expression right into your calculator like I did. And this segment 2 has slope 1/4, which we suspect by looking at the picture. So I know now that segment AB is parallel to side CD, and I have to state the reason why, because they have the same slope. So there's one pair of parallel sides. I need to now go and show that that same pair of sides is also congruent. And in order to do that, I'm going to use the distance formula. And again, remember that anytime I use a formula, the very first thing I need to do is put that formula down on my page. So I'm going to go ahead and find the length of AB first. So the x values are 3 and -1. and the y values are 4 and 3. And I'm going to go ahead and plug that into my calculator. And when I do plug that into my calculator and let it earn its keep for me, I find that the length of that segment is equal to the square root of 17. And I'm going to go now do the same thing for segment CD. And that too, when I plug it into my calculator, is the square root of 17. So now what I found through the distance formula is I found out that segment AB is congruent to segment CD because they have the same length. So now I've got the same pair of sides that's both parallel to each other and congruent to each other. That makes my quadrilateral a parallelogram. So my final concluding statement is going to be to say that quadrilateral ABCD is a parallelogram because the same pair of sides is both parallel and congruent. So again, the word both, and it's got to be both of these things, both parallel and congruent. I might want to specify that my sides are AB and CD, although I did already specify up here when I talked about them being congruent because they have the same length, and parallel because they have the same slope. Like always, I want you to take a few minutes to roll around in your brain everything that you just saw. There was a lot of information there regarding parallelograms and their proofs. Summarize your key ideas and important understandings, and then see if you can apply your newfound knowledge to solve the problems on page 12.